Welcome to 2023 with Agnes Kunkel. In 2020, the world was hit by COVID-19. It was like a time machine. Find out what the world might look like in spring 2023 and how we will need to adapt. 2023, your window to a world beyond COVID-19. It's Friday morning. The Miller family is sitting together for breakfast. Thomas's phone rings. It's Daniel, the family's lifelong friend. Thomas answers and sends his greetings from the kids and Xenia to him. Tonight is Daniel's birthday party, and he was inviting them to come. Thomas notes down the time and place of the party, wishes Daniel a happy birthday, and hangs up. Now let me go to work and then find a nice present for Daniel, says Thomas. Xenia says she will be doing the same, and they leave to work and take the girls to school. In the afternoon, Thomas and Xenia discuss whether it would be safe for them and wise to go to the party, or should they just celebrate with Daniel another day separately. Xenia argues, "Given Daniel's nature and personality, I don't think he will be inviting too many people." Thomas agrees and comments that Daniel booked the whole place so there would be a big space only for them. Melanie comes in to remind her parents to look up the restaurant on the internet for sanitation rating and AC purifying technology. The whole family stares at the computer screen eagerly and then are happy to see that the restaurant possesses a high ranking regarding AC technology and sanitation measures. Now they are relieved and very excited about going to the party, so they go to get themselves ready and leave. Once the family arrives and enters the restaurant, they notice the difference in the air quality between being outside and inside the restaurant. "How refreshing! It smells just like the air inside an airplane," commented little Christy. Thomas replies that they use a similar AC technology. The kids run to Daniel to give him his presents and wish him a happy birthday.
We are still in the COVID-19 pandemic. The total confirmed cases have reached today 14.5 million people. The global number of casualties has now risen significantly above 600,000. Today we have 20th of July 2020 and my name is Agnes Kunkel. I am your host, and today we are happy to introduce Dr. Bahnfleth. He is a professor of architectural engineering at Penn State University. He holds a PhD in mechanical engineering and is a registered professional engineer. His research focuses on thermal and air quality control systems for buildings. A major component of his research is the study of the control of indoor microbial air contaminants using ventilation, filtration, germicidal ultraviolet disinfection. He is a past president of ASHRAE, American Society of Heating, Refrigerating and Air Conditioning Engineers, and the chair of ASHRAE's Epidemic Task Force. Welcome, Dr. Bahnfleth. It's a great honor to have you here in our podcast in Germany and have a transcontinental interview here. When COVID-19 started, everyone was talking about washing hands and hands to keep it clean. But now we have learned that hands are not the real problem. And as long as you do a normal hygiene, but that aerosols as a transmitter of COVID-19, especially in closed rooms, are a big problem. I guess that's one of your specialties. I think you have researched exactly on that stuff.
Yes, that's just by coincidence been something I've been studying for close to 20 years now. I became interested in it actually when one of my graduate students back around 1998, 1999 read a book, I think it was called Epidemic or something like that, but it was about a worldwide epidemic that was killing millions of people. And he read that book and became very interested in controlling airborne microorganisms, and that got me started. And we did a lot of work related to bioterrorism around 9/11 when anthrax was being mailed to buildings. in the U.S. and did a lot of things that are similar to what we're doing today. That was when I got started looking at germicidal ultraviolet light as a disinfectant. But all of that went away, and it's been pretty quiet until COVID-19 came around, and now suddenly it's everyone's concern in a way that never has been before.
So I guess you are quite a popular interview partner at the moment.
I'm certainly getting a lot of requests to talk to the media. I think everyone wants to know what it takes to be safe inside of a building, and will my air conditioning system give me COVID-19, or if it can be prevented, what do I do to it so that doesn't happen? How do I know if it's safe to go into a restaurant? There are just lots of questions coming from different quarters, and quite understandably, because everyone's life has been disrupted by the pandemic. We're all trying to figure out how to get from where we are back to something that feels normal.
Yes, hopefully. The HIO guidelines now state that airborne transmissions may be possible indoors. I guess it's quite sure they are a major source. What about ventilation and filtration to reduce the airborne concentration of the SARS-CoV-2 virus and the risk of transmission? Do you see it's the same as WHO?
Yes, actually, REVA, the European HVAC Federation, as well as ASHRAE, said 4 or 5 months ago that we really thought that based on what we had seen in reports of super spreading events, that we ought to be taking precautions to lower airborne concentrations of infectious aerosols. So that's what those different modalities you just mentioned, those different methods addressed. Ventilation dilutes indoor air with outdoor air that's free of infectious material, and filtration removes particles that may contain viruses. And we can also use other types of air cleaners to inactivate or kill them, if you will. Because the most important thing, if aerosol transmission is possible, is to keep the concentration in the air low enough that it takes a very long time to be exposed to enough of it to have a high risk of infection. So the only thing we're trying to do is keep concentrations of a certain contaminant low indoors using methods that we've used really for over 100 years.
And what are these methods you are typically recommending to keep the virus concentration low in an indoor facility?
Well, certainly a good supply of outdoor air is fundamental. We bring in outdoor air for ventilation to control all sorts of indoor contaminants. There are thousands of contaminants that are inside of a building that come from building materials, like the glue and resins in flooring and carpets, and particulate emissions from indoors. So we use that as our general purpose air quality control, also human odors as well. So that's fundamental. Particulate filtration is something that has generally been done at a relatively low level in buildings, mainly to protect air conditioning equipment, to keep it from getting dirty. Increasingly, the changes in requirements for buildings have been increasing the filtration requirements to levels where we're using filters that are efficient at capturing particles that are in the size range of respiratory droplets, respiratory aerosols. Term that nobody probably knew before, and everyone knows now. We understand that when we breathe or speak or sing or cough, we're producing thousands and thousands of small droplets that may have viruses in them. And we're recommending filters that are efficient enough to remove those at a fairly high level to reduce the concentration. And to that we add things like germicidal ultraviolet, which is very effective for inactivating viruses on particles in the air or on surfaces.
Is it still used to use ultraviolet light to in a broad scale, let's say, yes, maybe in a broad scale, to use ultraviolet light to kill viruses?
Well, yeah, it's been interesting for me to talk to people from many different countries during the pandemic, because I'm more accustomed to the way things are done in the U.S. And from my point of view, we've had a fairly robust ultraviolet air and surface disinfection industry here for some time, for one to two decades. It's not nearly at the level of the air filtration market, but we have lots of manufacturers who produce systems not just for healthcare facilities, but also for office buildings and even homes. I know companies that mainly serve a residential market. So you can get UV equipment for all of these different types of buildings, but I would say the most common is healthcare. UV has been studied a lot as a control for tuberculosis, and has been deployed around the world as a way of reducing tuberculosis infection risk, for example, in a sanatoria that might have tuberculosis patients in it. So the CDC in the U.S. Approves the use of ultraviolet for tuberculosis control in healthcare facilities. But now we're seeing that technology being considered for other applications like large high-density spaces that you might find in some buildings, or perhaps a concourse in a transit facility where you have a lot of people coming through, and it's hard to keep the air clean by other methods. So we see a lot of interest in those applications and in office buildings, as well as a way of ensuring that the air is as clean as we can get it.
Do you think that these air conditioning system or the HVAC systems will be given a higher priority in the construction of new buildings over the next few years?
I certainly think in new buildings we may be seeing differences in design that incorporate better ability to control infection risk. I think we'll see also a lot more attention being paid to the maintenance of existing systems. I think that's one of the big issues with the risk posed by air conditioning in a lot of buildings, is that the systems are old and not well maintained. And the first thing we have to do is make sure that they're actually performing the way they were intended to. For new systems, I think we'll see perhaps differences in how much outside air is provided and what types of air cleaners are used, and perhaps the way air is distributed in buildings as well. There's been a lot of discussion about whether we should recirculate air inside of a building because it could take infectious material, say from the room a sick person is in, and carry it to another room and infect them. That seems very unlikely to happen with COVID-19 based on the data that we have on places where there have been super spreading events. But there are other diseases like measles that are much more contagious, have a much higher, not to use another term that no one had heard of a few months ago that everyone knows now. So those highly infectious ones that only require a few microorganisms to cause an infection might be a concern. But a lot of that has to be worked out, I think, carefully before we change standards. We're doing a lot of things right now based on what we know about COVID-19 and not necessarily about the broad spectrum of infectious diseases. And I think that not everything that works with COVID-19 will necessarily work with a different pathogen. So we need to take a broader view of it before we do something.
It's not just for one pandemic, which is over. We have to think about many other germs and many other possibilities of contagious material that should be kept out by a good purification system.
Yeah, exactly. Yeah, winning the last battle is not often a really good
start for the next one.
Yes, think ahead.
Yeah. Here in Germany, and I guess it's not so different in US, we have a big discussion about large indoor events. And a large indoor event at the moment here in Germany might be a theater, cinema, a big restaurant, concert halls, as these area of the economy are really near a complete collapse. I guess in New York, all the Broadway theaters are closed and all that stuff. Though, is there, during the pandemic, are there solutions from the air purifying side that might allow to maybe start conventions again for some, let's say, technical reasons, or you have these congresses and all that stuff that maybe for Ashra, I guess you have conventions. So is there a possibility by air and purification and filter systems to hold earlier such big events?
It would help if we knew more about how infective SARS-CoV-2 actually is. One of the problems with being able to say this is really a safe space is that we don't know as much as we would like to know about how much infectious material an infected person puts out when they're speaking or singing or playing a musical instrument, and what the dose is to cause an infection. So if you don't really know very accurately what the source is, and you don't know very accurately what the dose is that you're concerned about, then all you can do is try to be conservative. And I certainly think that some of the air cleaning options that are available could be helpful. So something like a concert hall is a place where you could use so-called upper room ultraviolet germicidal irradiation to provide protection. That's actually a very good way of applying it. We sometimes talk about in terms of how much outside air it's equivalent to perhaps 10 air changes or more, which is a very high level.
That's great. But it sounds a little bit like science fiction. How does this work? What are you meaning by upper air?
Well, yeah, we have upper room systems because germicidal ultraviolet produced by mercury vapor lamps, the same technology as fluorescent lamps, which LEDs are now replacing for lighting our buildings. It actually produces a lot of UVC, which is germicidal. So a fluorescent lamp has a glass tube with a phosphor on it, and the UV that's produced in the lamp is absorbed by that phosphor and radiates as visible light. So if we have a transparent tube made out of quartz, then the germicidal UV is emitted, and what it does is damage the DNA or RNA of bacteria or viruses, and if there's enough damage, then they can't reproduce. It's a very well understood and simple process, and we're simply trying to deploy this UV in a way that's safe. And the thing I think I didn't get around to saying was you can't shine a mercury vapor germicidal lamp on a person because they will get the equivalent of a bad sunburn from it, and their eyes will be irritated as well. So we put it in the upper space in a room so that air circulates there and is disinfected, but the people aren't exposed and are safe.
So it's when you have a high concert hall, you would put it up under the ceiling, or?
Yeah, if a space has a ceiling that's at least perhaps 3 meters tall, then you can safely install these lamps there. You may not put it all the way on the top of a huge concert hall because you actually want to be treating the air that's down where the people are. It would be above where they're sitting. One thing that I mentioned in a discussion with some performing arts center people in the U.S. last week was that these fixtures do give off a little bit of blue light, and I wonder how they feel about having something in their concert hall during a performance that's glowing blue. It might be a little distracting, but if that's what it takes to actually be able to have a performance.
I would guess people would accept this when they could start doing concerts and performances and shows and all that stuff.
Yeah, and of course, the air is often supplied under the seat because you're in these big high ceiling rooms, and you can also put UV into the air conditioning system and treat the air that's supplied, so you're getting cleaner air. There are a lot of different ways to do it. It's not magic, although I remember the first time I heard about light disinfecting things, I thought that sounded like it was questionable. Could that really be true?
But it does work.
It is.
Are you doing research on these ideas?
Yes, I have a project going right now that has two parts to it. In one, we're actually studying coronaviruses in the laboratory and testing them with germicidal light to determine what their susceptibility is. In order to be able to design a system, we need to know for a specific pathogen what dose it takes to reduce its concentration by a large amount. So we're doing that. We're working with a surrogate coronavirus right now, one that causes colds in people. But within the next few weeks, we're going to be looking at SARS-CoV-2 itself, which we don't expect to be different by very much, but it still needs to be confirmed. And the other part is doing studies of application of UV in typical spaces. So we're studying what is the best way to apply it in combination with filtration and outdoor air so that we get a good result low energy use and cost effectively, which always is part of the thinking when your engineer is doing systems. Something may work very effectively, but if it is so expensive no one can afford to do it, then it's not going to be widely adopted.
So when we think about the short narrative at the beginning of our episode, it was about going to a restaurant and not asking for the quality of the dessert, but asking about the quality of the air conditioning and if it's safe and all that. Do you think this high interest in your field of research, that it will last, and that really in 2 to 3 or 5 years people have much more, let's say it's a much more point of interest? What air cleaning system do I have in the building? Does it bring in fresh air? Does it kill germs? And I guess there are many other germs like these typical respiratory stuff that you have. Maybe people get more demanding and saying, I don't want to get cold. And we don't want to get other influenza viruses in our buildings and all that stuff. Do you think that the interest will stay?
Well, I certainly hope so. We have a number of examples where there's been a serious epidemic, though, and the memory has been very short. Once things are over and we go back to normal, the public forgets all about it, and then people start saying, well, that would be nice, but it's very expensive. I think that perhaps we've suffered so much personal and economic damage on such a scale from this pandemic that we have a longer window of opportunity to do something. But I'm not feeling comfortable that we have a long time to make changes. So I think we're going to have to work very hard after the pandemic is over and we have our thoughts in order about how to change design standards and what to recommend as far as technology for making buildings safer. And unfortunately, there are a number of things coming together here. One is the whole wellness movement in buildings.
Yeah.
I think the public has become aware of that. And I think we tie infection control when there's a pandemic in with simply making buildings healthier all the time. And I think there are cost-effective solutions there if our technology keeps developing. And the other thing is resilience. There's been a lot of discussion about designing buildings to adapt to climate change. So if the climate keeps getting warmer or it's getting humid or wetter, that affects the way that HVAC systems have to function. So we've been thinking about that as well. And dealing with pandemic is essentially having resilient systems in your buildings to control infection. So I'm hopeful, but it will be interesting to see how far we can go with some of the things that are under discussion now. As far as restaurants, a lot of people ask the question, how do I know if the air quality is good or if it's safe? And it's really very hard to tell. It's easier to tell when air quality is bad because of odors than to tell if it's good. It's really hard to look at air and say, well, there's a lot of PM 2.5, 2.5 micrometer and smaller particles in the air. They're not really visible, so you can't tell from looking at the air whether the filters are good. Some people are talking about taking carbon dioxide monitors into restaurants and trying to judge from the CO2 concentration whether there's good ventilation. Maybe in the future we'll have personal air quality monitor, something in your phone. You could test the air in the space that you're in. There are apps like that now, actually, but not everyone is using them. But I think another approach that would really be helpful would be air quality certifications for buildings. We have energy regulation for buildings. Why shouldn't they be certified as to the quality of their air and their safety? And I think there's a good reason to do that.
I could imagine that people demand that even if it's not mandatory, if it's just a free choice of the owner of a restaurant or a gym or whatever, that it's a certain quality you can add to your service showing that you have good air conditioning. And as we discussed in the beginning, I guess maintaining air conditioning systems or these heating, refrigerating and cleaning systems is a very big point, as I have a little bit the feeling you build it, when the building is done, then okay, it's nice, but afterwards people forget about it.
Yeah, and certainly a building that's working satisfactorily for many maintenance organizations that have limited budgets is one that people aren't complaining about.
Yeah.
And often when you actually look at them, there are lots of things wrong, and not just with affecting air quality, often energy as well. It's been said for forever throughout my career that if we could just get all of the HVAC systems to work the way they're supposed to, we would immediately reduce their energy use by 15 to 30%. So there's a huge energy expense that we're just living with because of that.
Yeah, that's amazing. That's amazing. Yeah, here we in Germany, of course, we always think about stricter regulations by the official side. I guess in your country, it's more about a free service that people expect. And what do you think it will cost to upgrade when you have now a restaurant, a concert hall, and you have a standard system at the moment? What amounts of money are we talking if you want to grade it up to clean it on a level where you can filter out viruses?
Well, my organization, ASHRAE, that is producing guidance on building updates, is only recommending an update to what we call in the U.S. a MERV 13 filter. I'm not sure exactly what that is in ISO or a European standards, but it's a filter of good efficiency, but not a HEPA filter like you might find in laboratories or hospitals. And those filters might cost twice as much as the ones that are being specified by minimum standards now. So it's an expense, but not a huge one. And they don't necessarily have larger pressure drops through them than the less efficient filters. So there may not be an operating cost impact. Increasing outside air, depending on the type of system that you have, may simply be a matter of adjusting the controls to reduce the amount of air that recirculates and to bring in more from outside. And so that doesn't have an equipment cost with it. It has an energy cost associated with it. And to mitigate that, to reduce that impact, then you might want to put energy recovery devices in your system. But again, it's a moderate cost. And if you're using UV, an upper room system, in U.S. dollars per square meter, the equipment might be $30 or $40 per square meter plus installation. So an upper room system is pretty expensive, but you be below $10 per square meter for a system that was put inside of an air handling unit. So these are not insignificant costs, but they're costs that a lot of facilities could afford. And when you think of the other side of the ledger, the health effects that people suffer because of poor air and lost business. There's no comparison. Those costs are 10 to 100 times the cost of the equipment and energy.
I have seen a figure about sick days when the air conditioning or the heating cooling system is not working well, and that was tremendous. What a good climate in the office building can mean for, or even when it's not good working, what this means for the sick days of the people working there.
Sick days, productivity, performance of children in school. There's just piles and piles of evidence that we could do better without really spending a lot more on our buildings.
Yeah. So when I think about what we have now to make some, to put it together, to do a resume of it, you say, first of all, at the moment, it's very, very much in discussion. And that the big point would be, first of all, to maintain the existing systems. And it would not only mean that we have better air quality in the rooms, we would also save a lot of energy. Just by regularly, in a real regular cycle, maintain it, change the filters, have a look if the maybe regulation systems are well working or whatever.
Yes,
and
soften the controls.
And what I was positively surprised is I thought that grading up air conditioning system would be very expensive. But when I understand correctly, upgrading mainly in the first step means new filters. So just by changing your filter partition could help a lot.
Yes, and of course, it's important to point out that not every air conditioning system can be upgraded to the level that is being recommended. They may have limitations in terms of the size of the filter racks that are in them, or there may be limitations in terms of how much pressure the fan can produce. And if you were going to go as far as is being suggested, you might have to make some physical modifications to the system. But in my own home years ago, simply because I wanted to have better air quality, I changed out the filters from very inefficient ones to the highest that I could put in, which is MERV 11, which is close to what we're recommending. And it caused no operating problems at all, and it keeps the air cleaner in the house. So I think it's affordable.
Yeah, I have these air cleaners. I have an allergic against this other biological stuff. And so I have air purifiers on HEPA level in all my rooms, and it wasn't expensive, as I guess in China they have it for the air pollution. And so it's of course, you have to change the filters from time to time, but it was really no real expense stuff.
No.
And the others for the resume, you are expecting some sort of apps or small measure units where you can go to a place and say, okay, I just measure now CO2 concentration or whatever, and want to be do my check on my own.
Yeah, I mean, these already exist, and I just foresee that people will want to have them, and the technology will get better. It's you have a sensor that you plug into your mobile phone, and the app will tell you what the measurements mean in terms of air quality. I certainly see that happening.
What type of sensors are these? Maybe our listeners are interested to plug in some sensor and to go to their office room and
Sure. Well, the things that are normally measured for kind of an overall assessment of air quality would be particles in the air. Better if you're measuring them within that fine size range that we know as health effects, 10 micrometers and smaller. And carbon dioxide, because it's sort of an indicator of how good ventilation is. And the other thing that is sometimes sensed would be volatile and semi-volatile organic compounds. So that these are the things that would be given off by building materials that are another component of indoor air pollution. So those are the main three things that I would expect to be represented, and maybe temperature and humidity would be rolled in there as well.
And I guess nowadays these sensors are not so expensive that it would not be able for a private person to buy it.
Oh yeah, if someone's really interested, it's something that they could afford. Not for everyone.
Okay, so we have it's a little bit more expensive, but maybe the more people asking for it, the cheaper it gets and will be. And so maybe in 2 or 3 years, it's just absolutely normal to have your air quality sensor.
I think it could be.
It could be. Okay. So hopefully you are very successful with your research on the COVID-19 germs and can help to solve these problems, maybe for services and concert halls and all this really hard hit communities. We always, in the end, our guests in this podcast ask about your personal experience. Well, of course, you have had changes in your life, in your research. Maybe the next semester will be online in your Pennsylvania state, I guess. When you think now 2 or 3 years ahead, what do you think you have changed during the pandemic and you will keep in the next years?
Yeah, well, given that I'm an academic and teach as part of my responsibilities, I think there will be big changes in teaching. I think we've found out that it's actually easier than we thought to do remote education, and universities were trying to go in that direction to build a larger audience for their classes already. So I think this will accelerate that. I also think that probably like a lot of other businesses, the university may be less concerned about whether we work from home. We've been getting by since the middle of March with the campus shut down. We finished the spring semester online. We're going to try to do some live instruction in the fall, but I think most of us are mainly going to be doing remote instruction with a little bit of contact, partly because when you distance the students in the classes, we don't have enough rooms that can hold some of the larger classes. It'll be interesting to see what happens, because things could change if the pandemic really heats up in my part of the U.S., then we could be shut down again by August or September.
Oh, let's not hope that. Let's not hope that.
Well, we'll hope not.
Okay, that was very, very interesting. I was sure it would be interesting, but it was even more interesting. And I'm really thinking about buying such a sensor to find out about the quality of air in my house and where I'm working. And so really, thanks a lot. And we wish you very, very well that it goes in a good way in Pennsylvania and that you have a lot of fun and new experience in online teaching.
Yes, thank you very much. It's been my pleasure to visit with you.
Yeah, thank you. Bye-bye.
Thank you. Bye-bye.
You've been listening to 2023. To get in touch with us with your comments or ideas, or if you'd like to be a guest on the show, just email hello@20-23.earth. You can find even more material, including transcripts of our interviews, on our website at 20-23.earth. Please keep in mind, the content of this podcast is our opinion. We work hard to get our facts right. However, if you find something that can be corrected or improved, please email us at hello@20-23.earth. If you haven't already done so, we'd be grateful if you would subscribe, rate, and review this podcast wherever you happen to listen. Thanks for listening, stay safe, and there will be springtime in 2023.